Hello, everyone. My name is Gabriel Potvin, and I'm a professor in the Department of Chemical and Biological Engineering here at UBC. I'm very happy to have this opportunity to tell you a little bit more about our programs and about what chemical engineers do. So chemical engineers are also called process engineers because we design and we operate processes or series of steps to transform one thing into another. Historically, the profession came about because of the needs of the oil and gas industry for the extraction and refinement of oil, but it is so much more now, and we're involved in so many fields, be it through renewable energy, medicine, materials, foods. There's chemical engineers working in all sorts of applications. So how do we design these processes? We spend a lot of time learning how the universe works. So the universe is made out of matter and energy. Once we know how matter behaves and how energy behaves, we can use that knowledge to bend the universe to our will, right? To make the universe do things it doesn't want to do naturally. And we use that knowledge to make all of those products that we need for everyday life. This is what a process looks like, just to give you an idea. There's no test at the end. This is just to give you an idea of the scale and the scope at which chemical engineers work. So the programs that we offer here, we actually offer two programs. So we offer chemical engineering and chemical and biological engineering. Both of these will allow you to graduate as a chemical engineer and work in any industry in which we find chemical engineers. The difference is you get to specialize a little bit based on your interests and on the tools you're going to use to design those processes. So in the chemical engineering program, we spend more time on the physics and the chemistry and process control. And on the chemical and biological engineering, we look at the tools offered by biology to make some products, because there are some products that we need that are much better produced by biological means. So you see a lot of applications on the screen of where chemical engineers work or problems that chemical engineers can tackle. So there's really two very special things about chemical engineering compared to other engineering disciplines. The first one, like you see on the screen, is we can work anywhere. This doesn't mean we're jacks of all trades. This just means that our skill set in the design and the analysis of these processes to see how everything fits together is really useful in every single field. So we have chemical engineers working in every industry possible and working on a very wide range of problems. The second thing, kind of tied to the first, is that because chemical engineers are uniquely suited to see processes, to see things on a larger scale, and to see how everything fits together, we're normally the ones in charge of the projects and the ones making key decisions about how something's going to be built. So you can see that big process that I showed you a couple of slides ago, and I would make decisions. I would go see a mechanical engineer and I'd say, look, I need you to build me a reactor of this size, out of this material, with this inlet port that can withstand this temperature. And then we let them sort out the details. But the mechanical engineer doesn't have that overview and really understand how all of the parts fit together. So because we're the ones that can see how everything fits together, we're normally the ones in charge. And I have some recent graduates, some of my students that graduated 3, 4, 5 years ago, that are now in charge of teams of tens or hundreds of people and projects worth in the tens of millions of dollars. So those are two special things about chemical engineering. So our programs here, someone must have told you in these orientation programs, the first year engineering at UBC is common for everyone. You get into general engineering, you do your first year, and you apply for your specialization at the end of it. Once you come in chemical engineering, regardless of those two programs, which one you're in, the second year is going to be common for everyone and really give you the basics of process design, as well as the chemistry and biology you need to be a good chemical engineer. Then in third and fourth years, when you specialize a little bit, your laboratory courses are going to be different. You're going to take some more advanced courses, depending on the topic of the specialization that you want. Something else I told you, chemical engineers can work in a variety of fields. You get to specialize a little bit, get some advanced knowledge in a particular field of interest, and you can see the certificates that we offer on the right, which is you take a series of courses around a particular theme or a particular topic, and at the end you get a special certification to show that you have that expertise. Just a little bit more about our program. So we do have state-of-the-art facilities, wonderful labs. There's some of our professors on the screen here. Everyone in the department are fantastic instructors, except for me, of course, I'm terrible, but everyone else is really, really great. So you really get to have this hands-on experience, work with world leaders in their fields, and really get skills to understand how these things are going on that will allow you to work in a variety of fields. So, in terms of the student experience, perhaps more important than our facilities or our professors, really the student experience here. And bar none, we have the best students of I would say, any department or any institution. Our students work in these design teams where they tackle real life challenges and they show their work and compete at the local, national, international scale. I told you chemical engineers can work everywhere. They're on every one of our design teams and in fact play leadership roles in our design teams. We have a wonderful undergrad council that organizes all sorts of events and supports for students. So it's a really fantastic student community. Some opportunities that you have, like every program, we offer the co-op program or the fourth year thesis. What I can tell you is in the department here, we really have this culture of to create opportunities for some of our undergraduate students, to give them opportunities to work in some of our research labs, for example, and to work with the department. So if there's an idea that you want to pursue, we usually bend over backwards to try to make it happen. So where can you work after this? I already told you, you can work pretty much anywhere, and the bulk of our students do end up in these technical design or operation or research and development fields. But something, because chemical engineers, like I said, are very good at seeing the big picture and how everything fits together, a lot of them go on to form their own companies, right? Form startup companies to work in rapidly changing high-tech kind of industries. So we have a lot of our graduates that end up in that field. And because the skills in kind of system design and analysis that we help students develop are useful everywhere, our students are quite successful in, non-engineering disciplines like medicine or law, because everything is a system, right? The human body is a system, the legal system is a system, and our students are really able to work within this and to bring their analytical skills to these fields. So there's a lot of opportunities when you graduate. Like you see here, here's several of our students from the last couple of years, and you can see the breadth of the industries in which they work. So Arc'teryx, for example, that you can see, the company that makes the rain jacket, Gore-Tex, that material that's waterproof, made by chemical engineers. We really have people that are appreciated in a very wide range of kind of industries, in fact, recruited for this. And this is whether they're the kind of industry job or consulting jobs or startup companies or some of the best graduate schools in the world, right? So our students are in high demand. And finally, I'll just leave you with this, right? The world is facing some pretty daunting challenges. In fact, that may be why you're interested in going in engineering, to help tackle these things. Every engineering discipline has a role to play in tackling these challenges. What I will argue is that chemical engineers have a leadership role to play, right? A leadership role to play in facing these challenges head on, organizing people in the efforts to tackle them. So I'll argue the world needs more chemical engineers, and I hope that you are going to kind of join us and develop into a career that allows you to make a positive impact on the world. And with that, that's the end of our short presentation here. I hope that answered some of your questions. I really do encourage you to reach out at the contact information that's on the screen. And yeah, reach out with your questions, and I hope we will see you at UBC and in the Department of Chemical Engineering very soon. Thanks.